All right, let's get into it. We're not just talking about some random new programming language here. Nope. This is actually a story about a huge crisis inside one of the biggest tech companies on the planet, and the brilliant, kind of simple solution they built to solve it. This is the story of Go. So to really get why Go even exists, you gotta rewind the clock. Picture this. It's Google, around 2007. The company is just operating at a scale nobody had ever seen before, right? They've got this one massive shared code base, and that sheer size was causing their whole development process to just grind to a halt. And this quote, man, it just gets right to the heart of the problem. C++, which was their main workhorse language, was super powerful, for sure, but it was also incredibly complex. As their systems got bigger and bigger, the time it took just to compile the code, to debug it, to get anything done was becoming a massive drag on productivity. They were literally drowning in complexity. So here's the key thing you gotta understand. This wasn't just about making the programs themselves run faster. The real challenge was making the process of building and maintaining software faster. They had to fix their own workflow. So what did they do? Well, their answer was to build a brand new language from the ground up. And the core idea, the whole philosophy behind this new language, was just radical simplicity. You see, instead of adding more and more features, like pretty much every other language was doing, Go's designers deliberately started taking them away. This wasn't some academic exercise. It was all about pure, practical software engineering. Now this is where it gets really interesting, because you can see the strategy behind Go's design. At Google, they had the raw power of C++, but man, it was slow to compile and just a pain to work with. On the other hand, they had the simplicity of Python, but it just wasn't fast enough for their big systems. Go was built to be the best of both worlds: insanely fast compilation, simple typing, and a game-changing concurrency model built right into the language. And yeah, this just shows you the hybrid they cooked up perfectly. They basically fused the runtime speed and the safety of a language like C with the clean, easy-to-read style you'd find in Python. What you get is a language designed for huge teams of engineers working on massive systems that have to last for a really long time. But look, just being simple wasn't going to be enough. Go needed a technical superpower to really make it in the modern world of multi-core processors and massive networks. And that superpower is concurrency. And this right here, this is Go's secret weapon. It's called a Go routine. Think of it like a tiny, incredibly cheap little worker. While older languages really struggle to manage, say, a few thousand of these workers, or threads, a Go program can easily run millions of Go routines at the same time. This is absolutely critical for modern servers that need to handle thousands of connections all at once. So to manage all these little workers safely, they came up with this really powerful motto. See, in most languages, you have all these threads trying to grab and change the same piece of memory at the same time, which is just a recipe for disaster and bugs. Go just flips that entire idea on its head. And it does this using something called channels. You can think of a channel as a safe little pipeline between two of those Go routines. So instead of fighting over the same data, they just pass messages back and forth through these channels. This whole design makes writing really complex, concurrent programs way simpler and safer. Okay, so you've got this simple, fast compile language, and it has this built-in concurrency superpower. So what? What does that actually get you in the real world? Well, it gets you the entire modern cloud. No, seriously, just look at this list. These aren't just a few random apps. These are the fundamental building blocks of cloud computing today. You've got Docker for packaging apps, Kubernetes for managing them at a massive scale, and tools like Terraform for building the infrastructure they run on. Almost every single major cloud-native tool you can think of has Go beating in its heart. The internet we use every day is literally built on this language. And the adoption by major companies is just mind-blowing. At ByteDance, the company behind TikTok, a whopping 70% of all their microservices are written in Go. That just shows you how well it performs and scales in one of the most demanding tech environments on the entire planet. And it's not just about scale, it's also about being efficient. When PayPal moved some of their key services from C++ over to Go, they saw a 10% drop in CPU usage. Now, that might not sound like a lot, but in a huge company like that, that's a massive saving in money and resources. It proves Go really delivers on that performance promise. This little chart here really puts it all into perspective. On one end, you've got Rust, which gives you the absolute fastest speed possible, but comes with a ton of complexity. On the other end, you've got something like Node.js. And Go? Go sits right in that perfect sweet spot, giving you almost all the performance of Rust, but with a fraction of the complexity. But, nothing in life comes for free. And Go's greatest strength, that radical simplicity we talked about, is also the source of its most common criticisms. It was all about making intentional trade-offs. Ah, yes. If you talk to any Go developer, I promise you, you will hear about this. The if error is not nil check. It's everywhere. And yeah, it feels a little clunky, and a lot of developers complain it clutters up the code. But this is a totally deliberate design choice. It forces the programmer to explicitly think about and handle every single error, which leads to much more robust software, even if it's not as pretty to look at. So the takeaway here is that these things, the wordy error handling, a type system with less power for abstraction, the way variables get a 0 value by default, these are not accidents or mistakes. They are the price you pay for Go's main benefits: lightning-fast compiles, code that's easy to read, and long-term maintainability across gigantic teams. Which kind of leaves us with this final thought to chew on. Go absolutely solved Google's problem, and in the process, it basically built the modern cloud. But is its philosophy, putting engineering simplicity above everything else, is that the right path forward for all software? Or is it just a perfectly crafted tool for a very specific, very massive problem? That's really the question Go leaves for the rest of us to answer.